So in this video, let's start with this first one, which is showing the special equations when we have vertical and horizontal lines. Vertical line is a line which is parallel to y-axis, and horizontal line is a line which is parallel to x-axis, correct? So let's start with horizontal line. So a line, either it could be above, suppose this is your coordinate axis, y-axis and x-axis. For this you have this as the origin, correct? Now for this here, you can either have your line which is a horizontal line above the x-axis, or you can have a line which is below the x-axis. So let's talk first of all about the line which is above the x-axis. So suppose its distance from the x-axis is a. So that means actually this point is what? This point is A on the y-axis, right? This is the label. So what is the coordinate here? The x distance is 0. Sorry, the x distance here is 0, right? And y distance is A, right? And you see at all the points here you have the distance as same. Why? Because this is parallel to x-axis, which is A. So you can write down the equation of line that here you see a trend. In order to write down the equation, what is the condition that you have? The condition you have is that the distance between the line L1 and x-axis is constant. And what is that constant? The value is A, right? And what is this distance called? The distance is represented by the coordinate y. Hence y is equal to A. Here is the condition that tell you that it is constant. A is some constant number, right? So this becomes your equation. As simple as that. Similarly, for the second case, when you have your equation lying below x-axis, which is parallel to x-axis, let's call it by L2. Here the distance is also, we are taking it to be A. At every place the distance is A. However, now we are measuring the distance from origin and we are taking it downwards. Hence, it should be the distance. Actually, this point is what? On y-axis, this point is minus A. So and this point is what? If you see in the coordinate plane, this point, the x distance here is 0 and the y distance is minus A. And at every other position, only the x coordinate varies. The y coordinate remains the same, which is minus A. Hence, here we have this condition that y is equal to minus A, which is constant, right? So therefore, this becomes your equation in this particular case. Next, let's see what about the equation of a vertical line. So for a vertical line, you can clearly see if we have these two as our coordinate axis, right, x and y axis, and we have some line L1 which is lying right to that of y axis, right, which is at distance b from y axis. At every place it is at b distance from y axis. So here if you notice that, what is this point? This point is b, right? So that means at every point, and what is the coordinates of this point? The coordinates b, the x distance is b and the y distance here is 0 because it is lying on x-axis, right? And so here you see at every place the x distance is being constant. Therefore, in this particular case, you have x is equal to b, correct? This becomes the equation of the line. In a similar manner, you can see that for the line L2, which is lying on the left of y-axis, which is also at a distance b from y-axis. So you see at every position the x distance is constant, which is b, but we are taking it on the left hand side, hence this point is minus b, right? So all the distance from the left hand side, they are counted as minus b. So here we obtain the condition that x is equal to minus b at every point. Therefore, this becomes the equation. So if your point, say P here, lies on this line, so its distance should also be minus b. So it should satisfy this equation here. So I hope you understood this concept of equation of horizontal and vertical line. In order to clear up the concepts further, let's look at the question here. In this question, they are saying you have to find the equations of lines, so both the lines which are parallel to the axis. So both x-axis right, and y-axis. Now notice that the use of spelling here, AXES, is used whenever we have plural terms. So because we had two terms here, and this AXIS is used whenever we have a singular term with us, right? So for the equations of line which are parallel to x-axis and y-axis and are passing through this point, so let's first of all mark this point. This is your point -2, 3 in the coordinate plane. So there are two lines which passes through. Is one line, actually there are infinite line. You can also have a line like this, you can also have a line like this, but the special lines here are only two, which are this horizontal line L1 and this vertical line, right, L2, correct? So we wanted to know what is the equation of L1. So you see, for L1, because this is a horizontal line, hence the y distance here is constant and it is equal to 3 in each case. Hence the equation of line is y is equal to 3. Similarly, for the second line L2, you can see the x distance is constant here for every place. Hence it is x is equal to -2. This is the equation for the second line. So I hope you understood how to solve such questions when we are given special lines which are horizontal and vertical lines. In the next video, we shall be talking about this point slope form. So I hope you understood this concept well. Well, that is it for this video. Thank you for watching.